Good morning, students. So last class we were discussing about alcohol, phenols, and ethers. Right. So we had discussed, we had started with preparation of alcohols, then we had discussed some of the examples, right? We had seen some of the questions. Then we started with preparation of phenols. So then, so now we'll start with the electrophilic substitution reactions of phenols. Okay. So what is electrophilic substitution reaction? How the phenol undergoes electrophilic substitution reaction. So OH group. So what is attached for this aromatic ring? So aromatic ring is present and OH group is present. So this OH group is attached to benzene ring. Okay, what happens when it is attached to benzene ring? It activates. So it activates. It towards the electrophilic substitution reaction. So whatever the incoming nucleophile is there, okay, the incoming nucleophile, what it will do, it will because of this presence of hydroxy group, okay, OH group, the incoming nucleophile will take the ortho para position. So you know what is ortho para position, right? Here, so this is ortho positions, right? So this is ortho position and this is para position with respect to your OH group. So the OH group, what it will do, it will attach to the benzene ring, it activates it towards the electrophilic substitution reaction. So whatever the incoming nucleophile is there, it directs it to the ortho and para position. So thus so it becomes electron rich due to the resonance effect. So because of the presence of incoming nucleophile, so it becomes it will be electron rich, and thus due to the resonance takes place, okay, because which is caused by this OH group. So we'll see some of the substitution reactions on phenols. So first is what, when you take 3 moles of Br2, okay, bromine. So when you take 3 moles of Br2, so in water, what you get is 2,4,6 tribromophenol. So you can see at ortho para position, right? So there is substitution. So the incoming nucleophile, what it will do, it will attack this ortho para position. Okay, so it is 2,4,6 tribromophenol. Then if you take bromine in CS2, Br2 in CS2, that is carbon disulfide, what you get a ortho, one is ortho product and one is para product. This para product will be always in major. Okay, so this will be in major form. So you can see whatever the incoming nucleophile is there. So which is the nucleophile here? It is Br. So in incoming nucleophile, it will direct to ortho and para position. So the third reaction is when you take phenol and you react it with concentrated HNO3 and concentrated H2SO4. So what you get is 2,4,6, okay, dinitrophenol. So this is picric acid. So remember this structure, it is very important. 2,4,6. So you can see at 2, 4 and 6 position nitro groups are present, and phenol, right? So this is 2,4,6 trinitrophenol. Okay, so this is, the name is picric acid. So phenol further reacted with dilute HNO3. So if the condition is dilute HNO3 at 20 degrees Celsius, you get ortho and para position. So these are nitrophenols. Nitrophenols at ortho and para position. Okay. Then here you can see if you react it with H2SO4. If you react with phenol with H2SO4, what you get is ortho and para sulfonic acid. Okay. So this is ortho and para sulfonic acid. So always the para products will be major. So these are some of the named reaction, very important named reaction. So phenol, when you react it with CHCl3, okay, chloroform. Chloroform is what? CHCl3 in a base like NaOH. Okay, what you do, first you treat it with chloroform. So chloroform, so there are some intermediate step. Okay, so it forms a carbene ion is formed. So the carbene is unstable. Okay, so this is further treated with your base. What is this? It is NaOH base. So it is a strong base. So what it converts your carbene ion, that is CCl2 into CHO. Okay, that is, it is converting it into a aldehyde. So that is upon hydrolysis. So this is, the name reaction is known as Rimmer-Timmer reaction. So this is a Rimmer-Timmer reaction. That is when you are converting your phenol into aldehyde. Okay, so there is a aldehyde group at ortho position. So the name is salicylaldehyde. So when you treat your phenol with carbon dioxide, okay, if you treat it with carbon dioxide, further react with NaOH, a strong base, further hydrolysis will give you a salicylic acid. At your ortho position, that there is COOH group. Okay, carboxylic group is present, carboxylic acid group is present. So this reaction is Kolbe's reaction. This reaction is Kolbe's reaction. Okay, so this is a second name reaction named as Kolbe's reaction. So next is what? So next is phenol when you treat it with zinc. So it undergoes what? It is a reducing agent. So there will be benzene. Okay, so benzene plus ZNO. Okay, so this is the side product form. So this is another reaction. So when phenol reacts with zinc, so zinc, it is acting as a reducing agent. So it is converted into a benzene ring. So this is a benzene ring plus ZNO. Okay, so this is the reaction. So we'll solve some questions. Paracresol reacts with chloroform in alkaline medium to give the compound A, which adds hydrogen cyanide to form the compound B. The latter on acidic hydrolysis give chiral carboxylic acid. The structure of the carboxylic acid is. So what will be the structure? So these are some of the steps. You have to follow these steps. There are some reaction conditions. Follow that. And what is the compound structure of the carboxylic acid? Okay. What will be the answer? How will we solve it? What do you mean by? So whatever the you get, it should be a chiral molecule. Okay, chiral means what? To the carbon, all the atoms attached to be different. Okay, so to the carbon. So we'll see this reaction. So I'll just solve it here. So the reactions goes like this. So paracresol. Okay, paracresol. They have taken the starting product as paracresol. So paracresol CH3 and this is OH, right? Paracresol with respect to OH, this is at para position. So it is paracresol plus what? It reacts with chloroform CHCl3 in a aqueous medium. What is aqueous medium? NaOH, or you can take KOH. What it will go? It will undergo a Rimmer-Timmer reaction. This is what? It is a Rimmer-Timmer reaction. So what happens in Rimmer-Timmer reaction with respect to your OH group? Okay, with respect to your OH group at this position, what comes? Aldehyde group will come, right? It will be aldehyde group. So this is OH. So with respect to OH at ortho position, your aldehyde group will come. Remaining will be same. Now this is what? This gives you a compound A. So we'll read it. Wait. So the what happens here? So paracresol reacts with chloroform in alkaline medium to give a compound A. So this is our compound A. Now to this compound A, what we are going to add? We are going to add HCN. So we are going to add HCN. Yeah. Now where does HCN takes adds up? Okay. So this is CH3. So what happens? So here it is OH. So across this carbonyl group, okay, across this carbonyl group, so across a double bond, your H and Cn gets added. So this is, it gives you a compound B. So this is your compound B. So this on further hydrolysis. So it undergoes further hydrolysis. So after hydrolysis, what will happen here? So this will be CH3. This will be OH. So here it will be C, OH, H, and COOH. So what is the correct answer? What is the correct answer? It is B. Yes, B is the correct answer. Okay, so B is the the correct answer. So like this, you are going to follow the steps. Understood? So this is the way you are going to solve. So this is a Rimmer-Timmer reaction. So remember what is the reaction conditions, which are the reagents which are used. Okay. So we'll go for the next question. So the structure of the compound that gives a tribromo derivative on treatment with bromine water. Yes, we had seen this. Which is the structure? Which is a structure, okay, which will give you a tribromo derivative. So tribromo derivative means what? OH. Okay, tribromo means 1, 2, and this position should be. So whenever the incoming nucleophile will be there, so it will attack which? It will attack the ortho para position. So if you want a tribromo derivative, your Br groups will attack here. Okay. So which are the this? Which is the answer? At B, so if you are telling B as answer, at ortho position, you can see CH3 is there, how it will attack the both the side. Okay, it should be empty. The space should be empty. Okay, if you have to select such a molecule, no, not B. B is not the correct answer. See, with respect to OH, at your ortho position means what? Your both this position should be free. Okay, and this position should be free, not C. C, what is the C option? C. Okay, ortho positions are free, but your para position is not free. This is also wrong. This is also wrong. Then, yes. So, the answer is D. Why C here? D. Okay. You can see these are the ortho positions where Br can get attached, and this is the para position, right? With respect to OH, you have to see. So this is the correct answer. So this is D. D is the correct answer. Understood? So next question. Orthonitrophenol is less soluble in water than para-nitrophenols. Because what is the reason? What is the reason why orthonitrophenols are less soluble in water than para-nitrophenols? What is the reason? Yes, answer. What is the reason why ortho-para-nitrophenols are? Yes. Lohit Kumar, yes. Correct answer is B. B is the correct answer. Yes. Okay. So ortho-para-nitrophenol shows intramolecular hydrogen bonding. So because of that, it is less soluble in water than in your para-nitrophenol. So just see orthonitrophenols, how it will show. You know how what is the structure of orthonitrophenol? So it is oxygen, right? OH. So this is O, H. This is nitro group, double bond O. Right. So this is intra. Intra means what? Within the molecule. Okay. Within the molecule, there is hydrogen bonding. So this is the correct answer. So orthonitrophenol shows intramolecular hydrogen bonding. So because of this reason, they are less soluble in water than your para-nitrophenols. The unstable intermediate dichlorocarbene. Yes, we had discussed it. So there is a what, when you react your chloroform with your phenol, there is a unstable intermediate form, that is dichlorocarbene, right? CCl2. So in which reaction, name reaction, does it form? Yes. In which name reaction does you get dichlorocarbene as an intermediate product? Yes. It is Rimmer-Timmer reaction. Yes. It is Rimmer-Timmer, not Williamson synthesis. Williamson synthesis is for preparation of your ethers. Okay, it is for ether. When your alkyl halide is reacted with alkoxide, sodium alkoxide. Okay, when your alkyl halide is reacted with sodium alkoxide, it gives you what? RO R dash plus NaCl. So this is your Williamson's ether synthesis, not C. It is D. Rimmer-Timmer reaction. We had just discussed in the previous slide, right? So next we'll start with the preparations of ethers. Okay, we'll start with the preparations of ether. What are the different methods for preparation of ethers? So first is acidic dehydration of alcohols. What do you mean by dehydration? Dehydration is nothing but removal of water molecule. Okay, when you remove water molecule, so alcohol. So 2 moles of alcohols are taken ROH. Okay, 2 moles of alcohol is taken. It is treated with what? It is treated with your concentrated H2SO4. Okay, what is the temperature? It is 140 degrees Celsius. What is formed is your ether. Okay, ether is formed with giving by giving water as a byproduct. So this is water. Dehydration means what? Removal of water molecules. So 2 molecules of alcohol is treated with concentrated H2SO4. So I discussed in the last class what is the role of concentrated H2SO4. It is used as a dehydrating agent. Okay, dehydrating agent is what? It is used to remove the water molecule. Okay, so it is dehydrating agent. So the example, one of the example is ethyl alcohol, right? 2 molecules of ethyl alcohol is taken, treated with concentrated H2SO4. What you get is what? You get your ethyl alcohol. So H2, right? One. So like this. So this is your, so like this elimination of water molecule takes place. So it gives you diethyl ether, diethyl. So 2 molecules are there of ether. So it is diethyl ether. Okay, so this is the reaction. So catalytic dehydration of alcohols. Okay, catalytic dehydration of alcohols. Again, the starting product here, reactant taken is your ethyl alcohol. So ethyl alcohol is taken. It is reacted with your aluminum oxide. Okay, Al2O3 at temperature 240 to 260 degrees Celsius. The product form is diethyl ether. The product form is diethyl ether. So here it is a catalytic dehydration. Catalytic means what? It is a okay, this is it is catalytic activity. What do you mean by catalytic? It is used as a catalyst. Okay, it is used as a catalyst to fasten the reaction. It is also here it is acting as a dehydrating agent. So it is used here as a removal of water molecule. So you can see here water molecule is eliminated, right? So this method is only applicable for primary alcohols only. So this is applicable only for primary alcohols. Since secondary and tertiary alcohols, when you treat it with aluminum oxide, if you try to do reactions on the secondary and tertiary, it will yield alkenes. Okay, it will yield alkenes at this condition. Okay, so next is the Williamson ether synthesis. What is Williamson ether synthesis? Okay, it is alkyl halide. So alkyl halide is there. Alkyl halide is treated with what? Sodium alkoxide. So it is treated with sodium alkoxide. It gives you ether. Okay, it gives you ether. So it gives you what? It gives you ether. So this is the reaction. Okay, so like this. So this will react. NaX will be the side product and RO R dash will be the main product. So it is ether. So this is example ethyl bromide. Okay, ethyl bromide is reacted with sodium ethoxide. You get diethyl ether. So this is the product form. So this is the preparations of your ether. So based on this, we'll solve some questions. So the reaction, okay, C2H5ONA plus C2H5I gives you C2H5O, C2H5, diethyl ether plus NaI. This is known as, which is this reaction? Which is this reaction? Yes, yes. Nandish Lohit Kumar, yes, correct. Correct answer is Williamson's ether synthesis. Yes, correct. Yes. Okay, so it is Williamson ether synthesis. Why it is Williamson ether synthesis? Because one is your what? One is your alkoxide and another is your alkyl halide. So this is giving you yes, Sandarya, it is correct. Yes, the correct answer is C. So we'll go for the next one. The chemical name of anisole is, yes, what is the chemical name of anisole? What is the structure of anisole? Do you know what is the structure of anisole? So this is the structure of anisole. Yes. Can you tell me the chemical name? Yes. Yes. Nandish, Harshita. Yes. Ravi Kumar, correct. It is D. Okay, D is the correct answer. It is methoxy. So this is a methoxy group and this is benzene, right? So it is methoxy benzene. Correct answer is methoxy benzene. Yes. Yes, many of them have answered. Yes, correct. Okay. From Williamson's synthesis, preparation of which of the following is possible? Yes, only symmetrical ethers, only unsymmetrical ethers, both A and B, none of the above. Yes, Ravi Kumar. Yes, C is the answer. Yes, yes. Many of them have answered it. C. Yes, good. Good. Many answers are coming. Yes, all have answered it right. It is C. Okay. So both A and B. So you can prepare both symmetrical and as well as asymmetrical ethers. So number of metamers, okay, number of metamers for ether represented by molecular formula C4H10O. Okay. So what do you mean by metamers here? What do you mean by metamers? So metamers, they are the isomers which have same molecular formula but different alkyl groups on the two sides of the functional group. Okay. So the isomer which is having same molecular formula. So metamers are nothing but they are having same molecular formula, but different alkyl groups are present on the both the sides, okay, of the this functional group. So this is the molecular formula given. Okay, C4H10O. So how many this can be represented? Okay, what are the different structure? So we'll write. So one can be CH3. Yes. Yeah. Already you have answered. Yes. Basavraj, Saundarya, Guru Sid. Yes, it is B. So how it is B? How it is B? So first you can arrange it like this. So this is the correct answer. Okay. B is the correct answer. So this is one. Then second way is how you can write is CH3. You can take, so this is what diethyl ether. The first one is diethyl ether. Second one is what? You can take CH3, 0. Okay, oxygen. Then you can take CH2, CH2, CH3. One is a propyl group, another is a methyl group. So it will be methyl propyl ether. Okay. Then another is what? CH3, oxygen. Okay. Then you can take CH3 twice, right? So like this, you can give the three structures. So these are the three metamers. Okay. So this is the correct answer. Identify Z in the sequence. Yes, which is the Z structure of Z? What is the structure of Z? So CH3, CH2, CH double bond, CH2. So this is what in the presence of, yes, Lohit Kumar, C is the correct answer. How you will follow it? First is what? HBr. Okay, there is a unsymmetrical alkene is present. So alkene, whenever you are going to add HBr, okay. So HBr in the presence of what? H2O2. H2O2 is what? It is a peroxide. So whenever you want to add your peroxide, whenever you want to add your alkyl halide across a double bond and in the presence of peroxide, what it will undergo? It will undergo anti-Markovnikov's rule. So anti-Markovnikov's rule, it will follow anti-Markovnikov's rule. So what is the first, you will yield? CH3, CH2, then CH2. So okay, CH2 and then it will be CH2 and Br, right? So this is the first product, X, Y. Okay, Y is the first product. Then further what you have to do, you have to treat it with C2H5ONA. Okay, sodium alkoxide. Sodium ethoxide is taken here. So this you're going to, so it will be CH3, CH2, CH2, CH2O, and C2H5. Okay, so this is the answer. So this is the answer. So correct answer is what here? It is C. C is the correct answer. Yes. Yes. May, so we'll go for the next one. So we'll see the chemical properties of ethers. So cleavage of RO R bond. Okay, RO R bond, that is the ether bond. So so RO R, so that is ether. So this is what it is, ether. So ether, when it is reacted with pentachloride, phosphorus pentachloride, okay, and you have to heat it. So when you react your ether with phosphorus pentachloride and you heat it, you get what? Alkyl chloride. So you get your alkyl chloride. Two molecules of alkyl halides are produced. So second is what? When you treat it with dilute H2SO4. Okay, dilute H2SO4 in water, it gives you, it yields you what? It yields you alcohol. Okay, it yields you alcohol. Then when you take alkyl halide, so this is what? It is alkyl halide. When you take excess of alkyl halide, it yields you what? Alkyl halide. Okay, alkyl halide. So this, what happens here? R, right? So this R, this bond will break. So there is a addition of X. So this is RX, RX. Okay, two molecules of, so it is two molecules of alkyl halide plus water. Then if you take only 1 mole, okay, if you take only 1 mole, if you take 1 mole, what will happen to this bond? So one will okay, so one bond will be broken. Okay, one bond will broken, and it so X will be this 1 mole of hydrogen halide will be added, and it forms alkyl halide. Then another bond is not broken. Why? Because there is only 1 mole. So this will remain intact, and it forms what? ROH. So this is ROH plus RX plus water molecule. Okay, so this is chemical properties. So by this is the cleavage of ROR bond. So by breaking this bond, okay, across this bond, this add up takes place. So these are the some of the chemical properties. So substitution reaction, what do you mean by substitution reaction? What do you mean by substitution reaction? One of the atom is being replaced by another atom. Okay, so here you can see substitution reaction. So it is diethyl ether, right? This is diethyl groups. So diethyl ether, when you supply chlorine, okay, chlorine in dark, the condition is dark, so it should be dark. So what happens? This H, okay, hydrogen is been replaced by your Cl. Okay, hydrogen is been replaced by Cl. So this is the first reaction, first substitution reaction. Another condition is where they have taken diethyl ether only. The Cl2, okay, Cl2 gas is passed, but it is in sunlight. So you're passing the sunlight, okay, you're passing the sunlight. So you're passing the sunlight. So what happens here? The another this both the hydrogen atom, okay, both the hydrogen atoms are being replaced by your all the, you can see here all the hydrogen atoms are replaced by your Cl group. So this is perchlorodiethyl ether. So this is perchlorodiethyl ether. Okay, so dark condition means what? You are restricting, only two molecules or 2 moles here only. This is added, two atoms of Cl are added here, okay, across this hydrogen atom. So one or two hydrogen atoms are being replaced by two Cl atoms. Here you can see Cl2 is there, and you are supplying continuous sunlight. So with this sunlight, okay, so what happens? All the hydrogen atoms are replaced by Cl. So this is one substitution reaction. So in the reaction, so this is a reaction. Okay, so anisole is given. Anisole is reacted with HBr. Okay, it is reacted with HBr. What are the products formed? Yes. What are the products formed? So anisole plus HBr. What is the product? Yes. It will be OH plus CH3 Br. Okay. So OH plus CH3 Br. So like this. Just a second, I'll show you. Okay, like this. So CH3 Br. So this is a substitution reaction. So like this. So many have answered it D. Yes, D is the correct answer. Okay, D is the correct answer. So next we'll go to the next one. When CH2. So when there is a, so this is the reactant. So this reacts with what? It reacts with 1 mole of HI. So one of the product formed is, yes, what is the product formed? What is the product formed? Yes, beta, I'll just show you. So how this reaction goes? No, not D. Well, I'll just show you. Okay. So this will be CH3. So you are reacting 1 mole of HI. Okay. CH. So this becomes CH2. Okay. Double bond CH. Then your. So what happens here? So this OH here. Okay. This bond breaks. Here this bond breaks in the presence of HI. So this is O. OH is added here. H is added here from this iodide. Okay, hydrogen iodide. H is added here. Plus what? CH2, CH3, CH2I. Okay, iodine is added across there. This is what? This is iodoethane. Okay, this is iodoethane. So this iodoethane. So this iodoethane. And another is, this is a vinyl alcohol. Okay, so the product, this is given as ethene. So we have found what? Iodoethane, right? So this iodine ion will attack the sp3 carbon. Okay, so this will attack the sp3 carbon. So whatever this is formed, you have got your one of the product as CH2 double bond CHOH. So this will get rearranged. How you can write this after rearranging? So this will be CH3CHO. Okay, so this is ethanol. So this is ethanol. Okay, this is ethanol. Ethanol means it is a alcohol. Ethanol means it is aldehyde. Okay, it is B. It is B. So this get isomerizes. Okay, it is said to be isomerizes. Why it is isomerizes? Because it is having same chemical formula. The molecular formula is same. Okay, it is just getting isomerized. So this is the major product. So this is a major product. Okay, with 1 mole of hydrogen iodide, you get, these are the side products. So what happens here? So across this oxygen atom, the cleavage will take place between the C carbon and oxygen. Okay, so this is the reaction. So when our alkyl aryl ether is heated with HI, it gives. So what is the reaction? So when alkyl in the presence of HI, right? It is a alkyl. So this is alkyl, aryl, and ether. Okay. When it reacts with what? HI. So what it gives? See what happens here. So this. So this will be what? OH plus Ri, right? So it is what? It is phenol and alkyl halide. Understood? It is C. C is the correct answer. So it is undergoing a substitution reaction, right? You can see it. So it is what? O, oxygen is getting attached to hydrogen from this hydrogen iodide, and the side product obtained is alkyl halide. Okay, so this is the reaction. C is the correct answer. So we'll solve some more questions. Yes. So what is the general formula for an aliphatic alcohols? Yes. For aliphatic alcohol, what is the general formula for aliphatic alcohol, not aldehyde? CHO is for aldehyde. Yes, Akash has answered it right. It is B. Okay, B. C. This is what, this is for Saundarya. Yes, it is B. Okay, this is your alcohol, right? R is alcohol. So aliphatic alcohol. So this is alcohol. Then this is for aldehyde. This is carboxylic acid. Okay, so it is B. RH is your hydrocarbons. Next, which of the following is true regarding polyhydric alcohols? What do you mean by polyhydric alcohols? Polyhydric. Yes. Lohit Kumar, yes, it is D. When you have more than 4 OH groups. Not B. Okay, when you have one C, when it is said to be C, when you have only one OH group, it is said to be monohydric. When there are two OH groups, it is dihydric. 3, it is said to be trihydric. Okay, and more than four are said to be poly. Poly means many. So it is the answer is D. Okay, it is 4 OH groups are present. More than 4. Which of the following types of alcohol contain a bond between sp2 hybridized carbon and OH group? Yes, Amruta, no, not Amruta, Ravi Kumar. Yes, it is D. D is the correct answer. D is the correct answer. So your OH group is attached directly to the carbon having double bond. Okay. So this is your vinylic carbon. So it is directly attached to what? It is directly attached to the, so OH group is attached to the carbon, which is sp2. It is sp2 hybridized. So this is called as vinylic. Now what do you mean by there is something called as allylic? Okay, allylic means what? OH group is attached to the carbon, which is next to a carbon double bond. Okay, remember this. So allylic. So this is allylic. What do you mean by allylic? So OH group is attached to the carbon. Okay, this is attached to a carbon. This carbon which is next to a carbon double bond. So this is an allylic and this is vinylic. So the correct answer here is vinylic. So which of the following terms does not describe? So what is the name? So it is just see what it does not describe. What do you mean by primary alcohol? What do you mean by primary alcohol? When the OH group is attached to only one carbon. Okay, so this is further attached to only one carbon. So this is correct. So second is what? Monohydric. So there is presence of only one OH. So this is also correct. Then allylic means what? Allylic means what? OH group is attached to a carbon. Okay, OH group is attached to the carbon which is next to a carbon-carbon double bond. Right? So that is your allylic. What do you mean by vinylic? Vinylic means what? Directly your carbon is attached to, so your OH is attached to the carbon directly to C. So here what you can see, not vinylic, it is allylic. Okay. So you can see the same structure, right? What is allylic? What do you mean by allylic? OH group is attached to a carbon which is next to, right? Where it is just here. So your OH group is attached to a carbon, right? What do you mean by allylic? Is that when OH group is attached to a carbon which is next to a carbon which is having a double bond. Okay, so this is allylic. What do you mean by vinylic? OH group is attached to a carbon-carbon double bond. Okay, so this is vinylic group. So the correct answer is C. C is the correct answer. So this is, okay, it is what terms does not describe, right? It is not, does not describe. So allylic also is correct, right? Allylic is also correct. So it is not vinylic. The correct answer is D. Yes, the answer is D. Okay, so it is describing primary alcohol. It is describing monohydric. It is describing allylic. So it is not vinylic. Vinylic means what? OH is attached to the carbon which is next to a carbon-carbon double bond. Okay, so this molecule which we had discussed now, it is having the allylic carbon, right? So it is D. D is not describing the molecule. So next, choose the most suitable classification for the shown compound. Yes, now this particular dihydric means what? Okay, we'll go from below. What do you mean by benzylic alcohol? Benzylic alcohol means CH2OH. Okay, OH is attached to sp2 hybridized carbon which is next to a benzylic compound. Okay, then next is what? Is it OH is attached to sp2 hybridized carbon and next to this? Is it a benzylic alcohol? No, it is not a benzylic alcohol. Dihydric alcohol means what? Two OH group should be present in this molecule. Are you able to see two OH molecule? No. So this is also wrong. Okay. Now secondary means what? Carbon. Okay. Carbon is attached to other two carbons, but here it is attached to three carbons. So this is also wrong. So the correct answer is what? Allylic. So OH is attached to a carbon which is next to a carbon-carbon double bond. So correct answer is B. Okay, B is the correct answer. Primary alcohols can be benzylic in nature. Primary alcohol. So we'll write one primary alcohol. Okay, so this is the primary alcohol. So is it benzylic in nature? What do you mean by benzylic in nature? OH is attached to a sp3 hybridized carbon which is next to a aromatic benzene. Yay. Yes, it is true. True. Okay, it is true. Correct. It is true. So it is benzylic alcohols can be, primary alcohols can be benzylic in nature. Which of the following compounds contain an aryl carbon? Okay, so you have, which is the compound which contains aryl? Aryl means what? There should be a aromatic ring. There should be a aromatic ring. So ethanol, no. Vinyl alcohol, no. So benzyl alcohol, they have not said it. Okay, so it is, yes, it is D. D is the correct answer. Okay, D is the correct answer. ROR. Okay, ROR, where R represents an alkyl or aryl group, is the general formula of which of the compound? Yes, ROR, what it represents? What does ROR ROR represents? Yes, it represents your ether. It represents your ether. Okay. What is ester? Ester is, this is your ester. Okay, this is your ester. What is aldehyde? What is a ketone? Right. So the correct answer is ether. Ether is ROR. Okay, or ROR dash. So this is correct. Yes, most of you have answered it right. Correct. Good. So we'll go for the next one. When the alkyl groups attach to either side of the oxygen atom of an ether is different, it is known as, yes. Okay, when the, so what it is known as, if on the either side the oxygen atom the groups are different, then either side of the oxygen. Okay, I'll give you example. CH3O C2H5. Okay, what, so either side of the oxygen atom, these groups are different, right? What it is called? Yes, it is called as mixed, right? Mixed. They are called as mixed. When you have same atoms on both the side, either side of the oxygen, then it is called as symmetrical. Okay, it is said to be symmetrical, or it symmetrical, or symmetrical, or simple, mixed, or asymmetrical. Okay, when you have either side they are different, then it is said to be asymmetrical or mixed. Okay, so it is mixed. Identify the simple ether from the following. Yes, which is a simple ether? Which is a simple ether? Simple ether means on both the side of the oxygen. Okay, it should have same groups on either side. Yes, Nandesh, it is D. Yes, D is the correct. Rakshita, yes, yes. Okay, yes, Soundarya, it is right. It is D. Okay, D is the correct answer. We'll move for the next question. Which of the following is not an aromatic ether? So which is not an aromatic ether? Which is not an aromatic ether? So if there is no benzene ring, yes, Lohit Kumar, it is correct. It is B. Okay. Yes, Harshita, Akash, yes, Guru Sid, yes, many have answered it as B. So you can see it is a methyl and a ethyl group. So it is not an aromatic group. So there is a presence of benzene ring, right? So this is aromatic ether. So this is not a aromatic ether. So B is the correct answer. Diethyl ether is a mixed ether. Diethyl ether. Okay, I'll write the structure. Then you can tell me C2H5 O C2H5. Yes, B. Yes, Akash, Amrita. Yes, many have answered. It is as a false. Okay, it is not a mixed ether. Yes, good. Okay, so it is a simple ether, or it is a symmetrical ether. Yes. According to IUPAC, what is the suffix used for naming alcohols? Yes, what is the suffix used for naming alcohols? Yes, Lohit Kumar. Yes, Rakshita. It is all. This is for, this is your general representation. OH is, they are generally representing. We have asked here suffix. Okay, it is suffix, not general representation. How it is represented? Alcohols are represented by ROH, but the suffix is all. OL. Okay, it is correct. Yes, Pavitra, Saundarya, many have answered it right. Correct. We'll go for the next one. What is the common name of butane to all? What is the common name of butane to all? CH3, CH, CH2, CH3. Okay, what is the common name for this? What type of carbon is this? What type of carbon is this? Carbon is attached to other two carbon. Then it is said to be Carbon is attached to other two carbon. Then it is said to be what type of carbon? Yes, Nandish, it is secondary butyl alcohol. Right. Yes. Pavitra, it is correct. It is secondary butyl alcohol. Yes. We'll move for the next question. How many carbon atoms are present in the parent chain of tertiary butyl alcohol? Okay. We'll write the structure of tertiary butyl alcohol. CH3, 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 and OH. Yes, tell me how many carbon atoms are present here? Yes, C is the correct answer. Yes, C is the correct answer. There are 4 carbon atoms, right? There are 4 carbon atoms. So it is C, correct. Most of you have answered it right. Yes, it is. Next. What is the IUPAC name of isopropyl alcohol? What is the IUPAC name of isopropyl alcohol? Okay, isopropyl alcohol, I'll write the structure. CH3, CH, isopropyl alcohol. Yes, it is propane to all. Okay, it is propane to all. Correct. Pavitra, Asha, yes. Amruta, yes. Shishma, yes. Many have answered it right. It is good. Okay, very good. So we'll go for the next one. Glycerol is a I'll write a structure, then you can tell me whether it is monohydric, dihydric, trihydric, or tetrahydric. So I'll write the structure CH2, CH, CH2, OH, OH. Yes, this is the structure of glycerol. So it is what? How many OH are present? How many OHs are present? Where you can see 3 alcohols, OH group. Yes, Nandish Kumar, yes, it is dihydric. Okay, it is identify the correct IUPAC name of the given compound. Yes, what is IUPAC name? I'll give the numbering. Yes. Three-ethyl butane to all. Okay. Identify the correct IUPAC name for the given compound. Yes, what is the name? 1, 2, 3, 4. Yes. Yes. Wait. You can number it like this. 1, 2, 3, 4, right? It is 1, 3 butane, 1, 3 diol, right? So it is C. C is the correct answer. Yes, most of you have answered it right. We'll go for the next one. Which of the following is an incorrect name for the compound with aromatic ring having hydroxyl group at para position? Okay. What is the incorrect name? Hydroquinone. Yes. C. Okay. C. C is the correct answer. Resorcinol. C. It is not at para position. OH and OH group. Okay. It is at meta position. Okay. It is at, with respect to this OH group, this is at meta position. So resorcinol is not the name of the correct aromatic ring having the hydroxy group at para position. Okay, so this is the correct answer. What is the common name of the simplest hydroxy derivative of benzene? Hydroxy derivative. Hydroxy derivative. Phenol is just a hydroxy group. They have asked you a derivative. Derivative, it is, yes, Nandesh, it is B. Derivative of, this is cresol. Okay, cresol. So it is a derivative. Okay, you can derive the cresol with the phenol. So this is the correct answer. We'll go for the next one. Which of the following phenols is not dihydric? Okay, it is not dihydric. So paracresol, the structure of paracresol is OH and CH3. Okay, catechol, it is OH and OH. Then your resorcinol is OH and here OH. Then your quinol, it is OH and OH. Yes, which are not having dihydrol, it is paracresol. Yes, correct answer is paracresol. You can see here all the hydroxy group, in this only one CH3 is there. Okay. So it is not dihydric. So two OH are not present. So it is A. Yes, correct. The compound orthocresol is named as 2-hydroxymethane benzene in the IUPAC system. It is true or false? It is true or false? Ortho? No. Hydroxymethyl benzene. Yes, it is false. Okay, it is false. Why? Orthocresol is what? Orthocresol. Orthocresol. With respect to oxygen at ortho position, you have your methyl group. Okay. So 2-hydroxymethyl benzene, IUPAC name. Okay. The IUPAC name of this, it is 2-methyl phenol. Okay. So it is false. What is the correct name of the following compound? What is the correct name? I'll give the numbering 1, 2, 3, 4. Yes, what is the correct numbering? Yes, C. C is the correct answer. But 1 in 3 all. Yes. Understood? Yes, we'll go for the next one. What is the correct IUPAC name of the following alcohol? Okay. So what is the name of this particular alcohol? What is the name? It is benzene 1,2,4 triol. Yes. Rakshita, Nandish, Radhariti. Yes, it is correct. Okay. So we'll go for the next one. What is the correct common name of 2-bromophenol? They have asked common name. They have asked common name for 2-bromophenol. 2, 1, 2, right? 2-bromophenol. What is the common name? Ortho-bromophenol is what? It is IUPAC name. It is IUPAC name. The common name is 2-bromophenol only. Okay, the common name is 2-bromophenol. 2-bromophenol. IUPAC name is ortho-bromophenol. What is the correct common name for this? What is the name? What is the name for this particular molecule? CH3OC2H5. It is not B. See the name. M come first or E comes first? This is a methyl group. This is a ethyl group. M come first or E comes first? Yes, it is ethyl methyl ether. Sorry. Okay, it is ethyl methyl ether. Okay, so ethyl methyl ether. So it is D. D is the correct answer. So it is the ethyl methyl ether. So identify the incorrect name for this. So you have to see which is the incorrect name. So this is the particular CH3OC6H5. Yes, why ethyl come first? Because here, according to alphabetical order. Okay, now ethyl. So this is what? This is a methyl group. This is a methyl group. This is a ethyl group. So according to alphabetical order, you have to name it. So this is E. So E comes first. So it is ethyl. Then you have to write methyl. Okay, ethyl, methyl, and then you are ether. So the name will be ethyl, methyl, ether. So you have to follow the alphabetical order. Alphabetical order. So yes, next we'll see this. What is the incorrect name for this? What is the correct name? Methyl phenyl ether. So this is also correct. Okay. This is the correct name. Methoxybenzene. So methoxybenzene. This is also correct name. Anisole. So this is anisole is also correct name. Phenetol. Okay. So this is the correct answer. Okay. So the answer is phenetol. So D. D is the correct. Okay. So it is the incorrect name for CH3O C6H5. So what is this phenetol? The structure is like this. Okay. So it is like this. Structure is like this. So we'll go for the next one. What is the IUPAC name of CH3O CH2 CH2O CH3? Yes, what is the name? What is the name? It is A. Okay, it is A. 1,2-dimethoxyethane. Okay, it is 1,2-diethoxyethane. So it is 1,2-dimethoxyethane. So we'll stop it for today. So we'll meet on Monday with the new chapter. Okay, please solve as much as questions. So we'll meet on